Welcome to Easy Math TV. This is a continuation of a topic that we started in the previous video to this one. It's probably going to be 3 videos in all that we're going to use to solve this problem that we were given to perform a hypothesis test when there was a claim made about the mean in a certain situation. So there was a claim made about the mean, and we are testing that by using a sample, simple random sample from that population, and we're going to determine whether the claim was true or false, or there may not be sufficient evidence to say anything. So we're going to see what it is that we can say. And in this video, I just want to go over how this spreadsheet was created. I don't want to talk about the specifics of the problem that we're solving, but just talk about how this spreadsheet was created. And draw your attention to the heading at the top. In row 1, type one sample hypothesis test of a mean. And in parentheses, sigma can be known or not known. So this will work in either situation, but this is a one sample hypothesis test of a mean. That is what our goal is here, to just create a sheet that can be used again and again. So my data, again, is in column A. So I'm reserving column A for any data that I might have. If you don't have any data, just leave column A blank and just type the word data as a heading up there, just for your reference, just in case if you ever have a problem that gives you data instead of telling you ahead of time what the mean and standard deviation are. Columns C and D, just as previous videos, that in this area of inference, because that's basically the major heading of this whole series of videos is inferential statistics. And when we're doing inferential statistics, you're going to have a lot of calculations that we need to do in advance. Those are in columns C and D. And then we're going to use columns F, G, and H for the useful information that's going to help us make our decision. So that's going to be the information that we need to make our decision. All right. And I'm not going to take any time at all to go over these formulas, but I will point out that in row 6, where it says sample standard deviation, that could also be a value of sigma as well. So if you're dealing with a problem and you were given a number for sigma, you can type that into cell D6. Otherwise, you can calculate the sample standard deviation. So in other words, that can either be S or sigma in that cell. In cell D4, we have our sample mean. And you'll notice that that is different from the hypothesized mean. So every problem is going to be different. There's going to be, when you're doing a hypothesis test on a mean, you need to be able to distinguish between the sample mean that you need for your calculation versus the hypothesized mean that is in the claim, that is mentioned in the claim, whatever claim is being made about the data. So those two numbers will be different. One of them is your sample mean, the other one is the hypothesized mean. And I've typed them in here. For the sample mean, we just did the necessary calculation. And for the hypothesized mean, I just typed that into the box, into the cell. Degrees of freedom we went over in a previous video when we were talking about confidence intervals. So I would suggest that you go back to the confidence interval video if you're not sure what that means. But essentially it's equals D7 minus 1. It's equals your sample size minus 1. And then I typed the confidence level in cell D13. That can be anything like 85%, 90%, sometimes it's 92%. Um, the most common one that you will see is 95%, and sometimes you'll see as upwards as high as 90, 98 or 99% confidence. So it depends on the context. It depends on the kinds of data that you're looking at, just how strong of a confidence level you need. And then these last two calculations here, you need your significance level. The significance level is equals 1 minus D13. And that has to do with how you determine how you're going to be making your decision at the end. The significance level is related to how we make our decision at the end. And then your t value is going into cell D15. And again, that's the same as a previous video, but I'll just walk you through the formula once. It's equals left parenthesis D4 minus D10, so x bar minus mu, close parenthesis, divided by the standard error of the mean, which is in cell D9. So t values can range, just like z values, they can range anywhere from like -5 up to +5. T values will typically can be wider, can be a wider range than z values. So don't be alarmed if you see like a -5 or a +5 there. That can happen. So, but t values really can be infinite. They can be infinitely large. The larger they are, though, the more rare that is. Like it shouldn't happen very often. But you can have t values negative, and you can have t values positive. So in F, G, and H, what I've done is I typed the three different alternate hypotheses that you could possibly have. So when you're doing a hypothesis test, you have to have your null hypothesis and alternate hypothesis written down. And in the video just before this one, we talked about the null hypothesis and the alternate hypothesis. So if you did not see that, go back and watch the video right before this one, and then come back to this. So these are your three alternate hypothesis situations. One is a greater than, one is a less than, and one is a not equal to. And you'll notice that each one of them is referring to the number that is in D10. That is your hypothesized mean. So the null hypothesis would be mu equals 2.2, but then your alternate hypothesis could be any one of these three things that you see here. Okay, so for each one, we're going to calculate the associated p-value. That's a probability, or it's an area under the curve. And what I did was I made sure that that all the numbers you see here in G5, G9, and G13, they're all going to be displayed as percentages, because I find that students just find that easier to read, okay, if you display it as a percentage. So for the greater than situation in cell G5, type equals t.dist.rt. It's important that you do exactly that, equals t.dist.rt, parenthesis, and then the number in D15, comma, the number in D12, close parenthesis. So you need your t statistic and your degrees of freedom. And to calculate the area that we need, or the p-value we need, is the t.dist.rt function. For the null, when the alternate hypothesis is mu is less than a number, then we need equals t.dist, parenthesis, D15, comma, D12, comma, true, close parenthesis. So that's probably the easiest one when you're looking at an alternate hypothesis that says mu is less than a number. When the alternate hypothesis has mu is not equal to a number, that's in row 13 down here. So in cell G13, you're going to type equals t.dist.2t, parenthesis, and then we need to take the absolute value of the number in D15. So it's ABS, left parenthesis, D15, right parenthesis, comma, D12, and now close the parenthesis on the t.dist.2t function. So you've got two sets of parentheses here. One is for calculating the absolute value of your t statistic. The other pair of parentheses is just for the entire t.dist.2t function. So again, if I just read that left to right, it's equals t.dist.2t, left parenthesis, ABS, left parenthesis, D15, right parenthesis, comma, D12, and then another right parenthesis, and hit enter. If you get an error, then maybe you forgot a parenthesis or you put it in the wrong place or something, but it just needs to be exactly the same as what you see here. And just make sure that you're referring to the cell that has your t statistic for the absolute value. And then the second thing after the comma, we need our degrees of freedom. Okay, so just make sure that you have everything typed in exactly that. So then just copy in column H here, just so that we have a visual, copy your significance level. So these are all the same formula. In H5, it's equals D14. In H9, it's equals D14. And in H13, it's equals D14. That's your significance level. So we will talk about this in the next video, but there is a decision that needs to be made. And that decision has to do with comparing the p-value that you calculated in column G with the significance level that you just copied in column H. All right. So at this point, you know everything that you need to know about getting your spreadsheet all set up like this. So take some time and create a sheet that has all of these things on it, and then come back and we'll actually finish that problem that we started. Like, subscribe, comment down below, share these videos with people that you think might find them useful, and I'll see you in part 3.